So this is the part 2 of lecture for the pharmaceutical packaging materials. So we have, in the previous lecture we have completed up to the glass material. Now we will start with the metals. So first metal is the tin. It is a malleable, ductile, highly crystalline, silvery white non-reactive metal. This metal acts as a catalyst when oxygen is in solution. Everyone has seen what tin is. So we will see the advantages for the tin. This metal is very resistant to the chemical attack. It readily costs a number of metals. Example, tin coated lead tubes combines the softness of the lead with the inertness of the tin, and for this reason it was formerly used for the packaging fluoride toothpaste. Disadvantage is tin is the most expensive metal among the tin, lead, aluminium and iron. Uses: tin containers are preferred for food like milk powder containers are coated with tin, and currently some eye ointments still packed in pure tin ointment tubes. Next is aluminium. We will see the advantages for the aluminium. Aluminium is a light metal, hence the shipment cost of the product is less. They provide attractiveness of tin at somewhat lower cost. The surface of aluminium reacts with the atmospheric oxygen to form a thin, tough, coherent, transparent coating of oxide of atomic thickness, which protects the metal from further oxidation. Disadvantages are: any substance that react with the oxide coating can cause the corrosion. Example, product with the oxide coating can cause the corrosion. Example, products of higher or lower pH, some complexing agents which are used in the formulations will cause the corrosion. As a result of corrosion process, H2 may be evolved. Uses: aluminum ointment tubes, screw caps, aluminum strips for the strip packaging of tablet, capsule, etc. Sometimes internally lacquered aluminum containers are used to stop the reaction with the containers. Next metal is iron. Advantages: iron as such is not used for the pharmaceutical packaging. Large quantities of tin, coated steel, popularly called tin, combines the strength of steel with the corrosion resistance of tin. Disadvantages: if an aqueous liquid can penetrate a pinhole or other fault in the layer of tin, which is virtually a short circulated galvanic cell is set up, and the intense chemical reaction which results bring about the rapid corrosion of underlying steel. As a further measure, the tin surface is lacquered. Uses: fabrication of milk containers, screw caps and aerosol cans. Lead. Advantages: lead is the lowest cost of all the metals used in the pharmaceutical containers, and it is a soft metal. So what are the disadvantages? Lead, when taken internally, there is a risk of lead poisoning. So lead containers and tubes should always have the internal lining of inert metal and polymers. Uses: with lining, the lead tubes are used for such product as fluoride toothpaste. Types of plastics. So plastics is the material which is widely and nowadays largely used, like in a large amount, and for the variety of products the plastic is used as an packaging material. Plastics are classified into two groups according to the behavior when heated. So whenever the heating of plastic is done, it reacts in a two ways. It has two properties. First is your thermoplastic type. So on heating, they soften to a viscous fluid which hardens against on cooling. Means once your plastic is melted, after cooling it hardens. Examples are polyethylene, polypropylene, polyvinyl chloride, polystyrene, nylon, polycarbonate, acrylic multipolymers, polyethylene, tetraphthalates, etc. Another point is thermosetting type. When heated, when this thermosetting type of plastic is heated, they become more flexible. They may become flexible, but they do not become liquid. Means it will stretch like an rubber. Usually, their shape is retained right up the temperature of decomposition. Because the high degree of cross-linking, they are usually hard and brittle at room temperature. Example: phenol formaldehyde, urea formaldehyde, and melamine formaldehydes. Additives for plastics. So this is the another topic which is covered in the material. Plastics are polymers which are prepared from monomers. Plastics may be used directly to form the finished article. It is used to add other substances for improved stability or in use performance. So there are different types of additives. First is stabilizer, second is antioxidants, third is pigments, fourth is fillers, plasticizers, and other agents like cross-linked agents, curing agents, activators, and accelerators. What are the advantages? It is low in the cost, light in weight, durable, pleasant to touch, odorless and inert to the most chemicals, that is unbreakable, and able to retain the shape throughout their uses. So these are the advantages of plastics. Disadvantages of plastic: it has poor physical stability, stress cracking, a phenomenon related to the low density polyethylene, and certain stress cracking agents like wetting agents, detergent, and some volatile oils. Last point for the disadvantage is grazing a surface reticulation, which can occur particularly with polystyrene and PVC have poor resistance. Demerits of plastic material: permeation, leaching, sorption, chemical modification, and alteration of the properties of plastic or product. So this is nothing but when plastics are used for the formulation, like large volume parenterals or small volume parenterals, what happens? Permeation is the permeation for the vapors, water vapors or so that permeation occurs through the vapors. Then leaching is nothing but it leaches some plastic materials into the formulations. Sorption means that plastic material will absorb some of the factors, moisture from the outside area to the inside of the containers. Chemical modifications: alteration of the properties of plastic or products. Next is rubber. Natural rubber consists of long chain polymers of isoprene units linked together in the cis positions. Its most important source is the tree Hevea brasiliensis, from which the latex containing 30 to 40% of the rubber in colloidal suspension excludes when shallow cuts are made in the bark. Compounding rubbers: some of the properties of raw rubbers, poor elasticity and sensitivity of the temperature changes, make it unsuitably for the production of most rubber articles. Physical and chemical properties of rubber are altered by the addition of some additives such as vulcanizing agent. Vulcanizing agents are nothing but the raw rubber which has the poor elasticity, so its strength is poor. It hardens when cold and becomes soft and sticky when warm. It dissolves in many solvents. So vulcanizing increases greatly the range of stress and temperature over which the material is elastic. Sulfur is vulcanizing agent and it forms the cross links between the long rubber molecules. Accelerators: these reduce the time of vulcanization and the amount of sulfur required. Example: 2-mercaptobenzthiazole MBT, tetramethyl thiourea disulfide. S is not required. S is nothing but your sulfur. Zinc dimethyl dithiocarbamate, vulcanizing with the S at room temperature. So these accelerators are used to accelerate the reaction of vulcanizing. Next is fillers. Two classes of fillers are added to the rubber. Reinforcing fibers are used to improve the physical properties. Example, carbon black, very finely divided carbon, zinc oxide, magnesium carbonate and calcium carbonates. Extending fillers are added mainly as diluents to reduce the cost and partly to facilitate manufacture. Example, talc and asbestos. Softeners. This facilitates the incorporation of fillers, makes the compound easier to manufacture. Example, pine oil, mineral oil and tar fractions. Then antioxidants. Antioxidants. The chain are broken at the double bond and the S links by oxidation, causing the softening and weakening. Deterioration is slowed down by including the antioxidants. Example, phenyl beta naphthylamine and para-hydroxydiphenyl. Pigments, these are the colors kind of thing. So oxides of iron and sulfides of cadmium and antimony, coal tar, dyes. Then lubrications. What are the lubricants? To assist the removal of rubber products from the mold. Example, zinc stearate, talc dusted before molding. Types of rubber. There are 4 types of rubber. Butyl rubbers. These are copolymers of isobutylene with 1 to 3% of isopropyl or butadiene. Second is nitrile rubber. Third is chloroprene rubbers, that is neoprene. These are polymers of 1:4 chloroprene. Fourth is silicone rubbers. Next packaging material is paper and boards. Paper based material includes label, cartons, bags, outers, trays for the shrink wraps, layer boards on the pallets, etc. The application as well as the advantages of cartons included is it increases the display area, provides better stacking for display or stock items, assembles leaflets, provides physical protection especially to the items like metal collapsible tubes. Third is fiber board, outer either as solid or corrugated boards also find substantial application for bulk supplement. Fourth is generated cellulose films. Trade names of cellophanes and ryophans is used for either individual cartons or to assemble a number of cartons. Film foils and laminates. Film foils and laminates. Regenerated cellulose film based on the viscose chemical used for manufacturing of rayon and laminating 2 or more types of films. Cellulose coatings, foil and paper play different roles such as supportive, barrier, heat shield and decorative. Aluminium foil even in the thinnest gauge offers the best barrier properties which are not approached even by the most impermeable plastics. Metallization, a relatively new process whereby the particles of metal are laid down onto the surface under the vacuum, can significantly improve the barrier properties of a metal, but these do not approach the properties of pure foil. In the newer technology, co-extrusion, a number of plastic piles are extruded in a combination to produce cheaper laminations, use of film foils and lamination, strip packs, blister packages and sachets. Diaphragm sealed for the bottles, liners for boxes either attached or loose bag in box system and bags. Foil blisters. When sealed with the metal foil cover, the blister can provide a hermetic pack, that is, an isolated system which excludes any exchanges of gases between the product and surrounding atmosphere. Packaging material with respect to the different dosage form. First is solid dosage form. We will see what solid dosage form requires what kind of material or what kind of packaging material has to be used. First is tamper resistance packaging, film wrappers, blister packages, strip packages, bubble packs, shrink seal and bands, foil papers or plastic pouches, bottle seals, tape seals, breakable caps and sealed tubes. So these are the solid dosage form requirement for the packaging material. Containers for the semi-solids and pressurized product, collapsible metal and plastic tubes, glass, plastic pots and aerosols. Containers for liquids or parenterals, single dose containers, multi-dose containers, airtight containers and light resistance containers. Closures are threaded screw caps, crown caps, roll-on and pilfer proof closures. Suppository packages. So suppository packaging is nowadays changed. Pouch type strip packaging. These strips of 4-ply material, that is poly, aluminum, poly and paper, inner layer poly and extremely outer layer paper. Strip pack is superior to the blister pack in the 3 ways. The product, that is suppositories, can be removed easily without breakage, which happens many times with the blister pack. Often, blister pack requires the refrigeration to avoid the deformities in shape. This is not in the case of strip package. Fourth is, strip pack is of 4-ply material, includes aluminum, which has better moisture barrier properties, and hence the product is more stable as compared to the blister pack, which is usually of PVC. Next, we will see the packaging of liposomes. Generally, hermetically sealed containers are used for the packaging of liposomes. Transdermal patches packaging, backing films, occlusive films of varied composition and or a thickness, adhesives, an adhesive layer incorporates the active ingredients featuring silicones, acrylics and or polyisobutylene adhesive formulations. So these are the materials which are used for the transdermal packaging. Next, here I have given the figures which are taken or which are pulled from the internet, and it says what is the Indian pharmaceutical packaging market size in the year of 2023 up to 2028. So this Indian pharmaceutical packaging material shows the market size in USD billions. So it shows how much amount, that is USD 15.75 billions, are opted, or the production of demand of that pharmaceutical market is there in the 2023, and up to the 2028 it will be USD 29.41 billions. So the CARG, that is CARG, is compound annual growth rate, which is 13.30% according to the research paper. That study period is given for 2017-2027. Base year for estimation is 2022. Market size in 2023 is USD 15.75 billions, and market size for 2080 is USD 29.41 billions. Cargill's compound annual growth rate in this period is 13.30%. Market concentration is medium. These major players are nothing but the companies which are investing and which are responsible for the pharmaceutical packaging materials, that is Amcor and other companies which you can see in the figure. Then another figure is taken out from the internet, which says what is the global pharmaceutical glass packaging market share, means how many percent of the market is consumed by the glass material by the product type. See, according to the product type, your glass bottles which are used is 31.7% for the bottles, and approximately percentage are given for the ampoules and vials, syringe and cartridge. So the overall CARG is 4.1 for the year of 2017 to 2027. International standards on packaging. A list is given below of the standards on packaging issued by the International Organization for the Standardization, that is ISO. As of 10 October 1998, starting with the four main standards, after which they are listed in numerical order. That is, first is your quality system, model for the quality assurance in design, development, production, installation and servicing, ISO 9001 in the year of 1994. Then the quality system for the model of quality assurance in production, installation, servicing, ISO 9002 in 1994. These are the standards given. Quality system, model for the quality assurance in final inspection and test, international standard ISO 9003 in 1994. The quality management and the quality system elements, part 1, guidelines, the international standard ISO 9004 1 in 1994, and the quality management and quality system elements, part 2, guidelines for the services. These are the different guidelines and ISO standards given for the packaging material. Quality assurance aspects of packaging. General considerations to ensure that the patient and consumers receives the high quality drug. High quality management system must take the following consideration into the account if the required quality of packaging is to be obtained. So these are the points has to be considered. The requirements of the national authorities and the relevant designations, the product, the production process, the manufacturers, that is internal policies, safety and marketing. Bad packaging, which is the result of deficiencies in the quality assurance system for packaging, can have the serious consequences, and packaging defects can create the problem that may result in the drug recalls. Such defects may include the breakage and the problems related to printing or inks or errors on labels and packages, inserts, patient information, leaflets. The use of GMP and the quality control will prevent the release of defective medicinal product. Packaging processes and equipments need validation and qualification in the same way as any other part of processing within the pharmaceutical facility. Quality control. The essential part of quality control is performed by the manufacturer during the development, production, release and post-marketing surveillance of entire medicinal product. That is the finished dosage form in its primary and secondary packaging. Taste and assay are normally carried out at room temperature between 15 to 25 degrees Celsius or up to 30 degrees Celsius in some climatic zones, unless otherwise indicated. The International Pharmacopoeia gives the alternative methods to be used if certain instruments are not available. Sampling is done. Sampling is used to check the correctness of the label, packaging material or container references, as well as in the acceptance of consignment, detecting adulteration of the medicinal product, obtaining a sample for retention, etc. The sampling procedure must take into account the homogeneity and uniformity of the material so as to ensure that the sample is representative of the entire batch. Testing program. Testing program for the pharmaceutical packaging material is done by the visual inspection, that is for the cleanliness and defects, test to identify the materials, dimensional test, physical test, chemical test and microbiological test. Protection of the environment. For the protection of the environment, greater attention has been paid to the disposable and recycling of waste, and legislation has been introduced in many countries. Packaging waste. Pharmaceutical packaging represents a very small percentage of waste, but its disposal can cause problems for the environment. Provision should be made for the proper and safe storage of waste material awaiting disposal. The toxic substances and flammable materials should be stored in suitably designed, separated, enclosed cupboards as required by the national legislations. Waste material should not be allowed to accumulate. It should be collected in a suitable receptacles for removal to collection points outside the building and disposal of safety and in the sanitary manner at regular and frequent intervals. Waste may include uncontaminated waste, that is assimilated to domestic waste like paper, cardboard, glass and plastic. Contaminated waste papers are paper, cardboard, glass, plastic. Example: waste that has been in a contact with the blood derived products, radioactive products and cytotoxic products. Methods of disposal of uncontaminated packaging. First, different materials are given. In the second column, it is given whether they are prone or recommended for the recycling, or they are landfill or incinerations. So the papers and cardboards are recommended for the recyclings, lesser for the landfills, and at a medium level for the incinerations. For the papers, glass and rubbers, the recycling, it shows that if the 3+ signs are given, it says highly recommended, 2 for recommended and 1 is for acceptable and NA is for not applicable. So plastics are recommended for the recyclings, acceptable if they are landfill and highly recommended for the incinerations. In the same way, a recommendation for the disposal has been given for the glass, rubber and metal. Evaluation parameter. We will start with the evaluation parameters of glass. So there are different evaluation parameters for glass. First is your powder glass test. From the glass containers, alkaline constituents like oxide of sodium, potassium, calcium, aluminum, etc. are leached into the purified water under conditions of elevated temperature. When the glass is powdered, the leaching of alkali can be enhanced in the powder as critical. The principle involves the powder glass test in estimate the amount of alkali leached from the glass powder, the amount of acid that is necessary to neutralize the released alkali. A specified limit is specified in the pharmacopoeia. The basic analysis is acid-base titration using methyl red indicator. Next test is water attack test. This is only for treated soda-lime glass containers under the controlled humidity conditions which neutralize the surface alkali and glass will become chemically more resistant. The principle involved in the water attack test is to determine whether the alkali leached from the surface of a container is within the specified limits or not. Since the inner surface is under test, entire containers and pool has to be used. The amount of acid that is necessary to neutralize the released alkali from the surface is estimated. The leaching of alkali is accelerated using elevated temperature for a specified time. Next, methyl red indicator is used to determine the endpoint. The basic is acid base titration. Procedure for powder glass test. Step 1 is preparation of glass specimen. Few containers are rinsed thoroughly with purified water and dried with a stream of clean air. Grind the containers in a mortar to a fine powder and pass through the sieve number 20 and 50. Step 2. Wash the specimen. 10 gram of the above specimen is taken into 250 ml conical flask and wash it with the 30 ml acetone. Repeat the washing decant the acetone and dried the specimen, after which it is used within 48 hours. Step 3. 10 gram of sample is added with the 50 ml of highly purified water, high purity water, into 50 ml flask. Place it in an autoclave at 121 degrees Celsius plus minus 2 degrees Celsius for 30 minutes. Cool it under running water. Decant the solution into another flask. Wash again with 15 ml of high purity water and again decant. Titrate immediately with 0.02 normal sulfuric acid using methyl red as an indicator and record the volume. Another test is water attack test. The procedure is: rinse thoroughly with the high purity water. Fill each container up to 90% of its overflow capacity with water and is autoclaved at 21 degrees Celsius for 30 minutes. Then it is cooled and the liquid is decanted, which is titrated with 0.02 normal sulfuric acid using methyl red as an indicator. This volume of sulfuric acid consumed is the measure of the amount of alkaline oxides present in the glass container. So for the powder glass test, type 1, type 2 and non-parental glass, the limits are given for 0.02 normal sulfuric acid is 1, 8.5 and 15.0. For water attack, if it is type 2 glass, the limit of H2SO4 is 0.7, and for type 2 over the capacity of 100 ml it is 0.2. Observations: the powder glass test type 1, limit is given for 1.0 and observed value is 0.8. And for the water attack test type 2, glass containers with a 100 ml capacity or less, it is 0.7 is the limit and the value is observed as 0.5. Quality test for plastic containers for non-parental preparations. Leakage test. First, the 10 containers are filled with the water and fitted with intended closures, and they are kept inverted at room temperature for the 24 hours. The test is said to be passed if there is no sign of leakage from any container. Another test is collapsibility test. This test is applicable to the containers which are to be squeezed in order to remove the contents. The containers, by collapsing inwards during the use, yield at least 90% of its normal content at the required rate of flow at ambient temperature. Clarity of aqueous extract. A suitable container is taken at a random and the unlabeled, unmarked and non-laminated portion is selected. These portions are cut into the strips, none of which has a total surface area more than 20 cm square. The strips are washed free from the extraneous matter by shaking them with at least 2 separate portions of distilled water for about 30 seconds. The processed sample is taken into the flask previously cleaned and with the chromic acid and rinsed with the distilled water. Then 250 ml of distilled water is added to the flask, covered and autoclaved at 121 degrees Celsius for 30 minutes. The extract is cooled and examined. It should be colorless and free from the turbidity. Next, quality test for the closures. Preparation of sample. The closures are washed in 0.2% weight by volume of anionic surface active agents for 5 minutes. Rinsed 5 times with distilled water and 200 ml water is added. Then it is subjected to the autoclave at 119 degrees Celsius to 123 degrees Celsius for 20 to 30 minutes, covering with the aluminum foil. Then the sample is cooled and the solution is separated from the closure A, that is solution A. Then another test is residue on evaporation. 50 ml of solution A. Solution A is nothing but which is prepared from the autoclaving. 50 ml of solution A is evaporated to dryness on a water bath and dried at 105 degrees Celsius. The residue weights should not not more than 4 milligram. If it is below 4 milligram, it passes the test, and if it is above the 4 milligram, it will fail the test. Next, quality control test for the cartons. Compression used to assess the strength of erected package, thereby estimating the degree of protection that it confers on the contents. This is usual for the products with a no inherent strength in one plane or another. Second is cartons opening force. The carton should spring open into the original shape without a need of unreasonable force. If the cartons does not spring open or buckles in on itself, it may cause problem on cartoning machine. So these are the quality tests for the cartons. So we have seen in this lecture from the metal pharmaceutical packaging material from metal to the last point up to the quality control test for the cartons. Here we will end our lecture.